Text segmentation is a fundamental and important task in computer vision, as the structure and structure of text are looser and incoherent. It is more challenging to capture fine-grained features of every stroke in the world. And to obtain high-quality segmentation for downstream tasks, significant well-annotated training data is necessary. However, most public datasets only contain English characters and numbers, and few will study Chinese, which limits the applications of text segmentation. In this study, we propose bilingual text segmentation (BTS), the first large-scale bilingual text segmentation dataset that goes beyond English words and digits, including also Chinese characters. From Figure 1, we can see that the fine-annotated bilingual dataset can beat the synthetic bilingual dataset, improve the performance of the existing shorter method with a large margin, and boost the overall performance in the area of bilingual text segmentation to a new level. BTS can be utilized for text detection, text recognition, text segmentation, and text level detection. It provides free-level annotations, including picture-level mask, character level, and text level collaterals, as well as transcription. Statistic comparisons are conducted between BTS and 5 other representative text segmentation datasets, as shown in Table 1. We can see that BTS contains the most character classes, since it is the only dataset which has annotations for Chinese. The figure below A and B show an overview of the top 30 Chinese characters and the top 30 English characters and digits in BTS representatively. The percentage of Chinese character and punctuations is 66.4%, and it for English characters and digits is 33.6% in BTS. Figure 3C shows an overview of the number of objects in tesseract and childline in BTS. Most images contain 1 to 8 text lines and 3 to 20 characters. Figure 3D shows the distributions of the text coverage ratio. The 14,250 images in BTS are split into training, validation, and testing sets with a ratio of 7 to 2 to 1. To better handle a variety of complex scenarios, we propose the Pirate Guide Text Segmentation Network (BGTS-Net). Figure 4 shows the overview pipeline of BGTS-Net, which consists of 3 components. First, the detection module, for example, DBNet, for highlighting the text that may contain text. Second, the base text segmentation module to extract features from the input image and its highlighted regions. Third, a segmentation head with several loss functions, including a character discriminative loss, a TV loss, and 3 items of picture-level segmentation loss on text and its boundaries to guide the learning of the whole world. We conduct experiments from 2 aspects. One is to analyze the performance of bilingual text segmentation on the proposed datasets BTS and on other datasets including TestSeg and the semantic datasets, whose results demonstrate that a high-quality and fine-annotated dataset is necessary and valuable to help boosting the model's performance and expanding the application scenarios. The other is to evaluate the performance of the proposed approach, BGTS-Net, whose result shows that by introducing the test period, BGTS-Net beats the other state-of-the-art methods on the task of bilingual text segmentation with at least 2.67% per promotion in FGLU and 1.74 promotion in F-score. Several examples of the synthetic datasets are shown in Figure 5. This shows the quantitative comparison between BGTS-Net and TestRNet. The implementing method adopted here is DeepFilm-V2, one of the state-of-the-art methods. It's shown that the mask of BGTS-Net contains fewer background noises and better capture the complete stroke of characters, and the implementing images suffer less from house as well. More cases can be viewed in the supplementary material. Another application is the expression recreation as shown in Figure 7. We propose BTS, the first large-scale bilingual text segmentation dataset that goes beyond English words and digits, including also Chinese characters.